Hello Washoe County, and thank you for watching my video. This lesson that I'm doing, I've actually done with an algebra class in Silver Springs, but because I didn't have students, I have my 3 boys helping me today. All right, so we've been talking about functions for some time. Who can tell me what a function is? Daniel.
A math equation.
An equation can be a function. Like what kind of equation? Can you give me an example?
An equation that you use for a graph.
The equation for like a graph of a line. So if we have our typical line, y equals mx plus b, we can say that's a function of x. What else do we know about functions?
One input always equals one output.
For every input that goes into our little function box, we get exactly one output. So it's a rule that we can use to take inputs and get something out. And today we're going to find a set of inputs and a set of outputs and see if we can develop a function rule. And we're going to do that with a game called the Towers of Hanoi. So I've already passed out these little towers and the worksheet. And what I want to start with is explaining how to play the game. All right? Has anyone played it before?
Yes.
Yes, some of you have, and some of you haven't, so I'll go ahead and explain the rule. The object of this game is to move all of the discs from one tower to the last tower. But the rule is that you can only move one disc at a time, and that a larger disc cannot go on a smaller disc. So this is illegal to put this on a smaller disc. It would have to go either here or back where it is. Looks like we don't have a room for this one without moving the smaller disc. So, on the worksheet I just passed out, I want you to look just at number 1. We have a chart, and we're going to look at how many moves it takes, the minimum number of moves it takes to solve the puzzle when we have 1 disc, 2 discs, 3 discs, 4 discs, and then 5 discs. You're going to have to look and see if you can figure out a way to figure out 5 discs because our manipulative only has 4. So go ahead and take 15 minutes to play with the game, talk to each other, and see what you can come up with for a minimum number of moves. At this point, we're going to time lapse because they've already had time to play with these a little bit before we started. And usually there's good discussion that goes on as they figure out the game. Let's talk about what we found, what our results are. Okay, so when we started with 1 disc, it's always good to go back to the basics. What would we do if we only had 1 disc? What would we do if this problem were simpler? We've talked about this before. Making the problem simpler, then what do you do? Okay, so with 1 disc, seems obvious. How many moves does it take to solve the puzzle? 1. And that is just simply moving that 1 disc to column C. What if we have 2 discs? How are we going to solve the puzzle then?
3 moves.
3 moves, you guys figured out. Now, as you're doing this, I heard some talking, and there's a way we need to begin when we start. Where should I put my first disc? On C or B?
B.
On B. Why?
Because the lowest, because the biggest disc has to go to C first.
The biggest disc has to end up on C. So we have to be careful which way we move it first. So with 2 discs, we came up with 3. All right. How about when you had 3 discs? What did you find?
You move to C again.
Why did you move to C? Did you find any rules, or how did you figure out where to put your first disc?
With 1 it goes to C, with 2 it goes to B, with 3 it goes to C again.
So with 1 it goes to C, with 2 it goes to B, so you found that there was a pattern. On the first one we moved it to
Odd numbers go to
C.
C, even numbers go to B.
Joseph's noticed that if you had an odd number of discs, you started C. If you have an even number of discs, you start at B. If I start at the wrong one, if I start here at B, then I'll end up moving my tower to B and then having to move it to C. So Would someone like to come up and demonstrate how to solve this puzzle? Go ahead, Daniel. And while he's doing that, tell me, what did you get? How many moves did you get for a 3-disc puzzle? 7 moves. Excellent. You won the game. All right, so how about 4 moves? How many did it take? 4 discs, not 4 moves. If 4 discs, how many moves did it take?
15.
Daniel?
15.
15 moves. 15 moves when we had 4 discs. Where did you start?
I started at B
Why?
because of the pattern and it's a new number.
Okay, where do we move the second disc?
To C.
See, what kind of patterns did you notice for this? What do we do next?
Put 1 on 2.
Put 1 on 2.
Do 3.
And then 3. Put 2 on
How did you know to put 1 on 4 and not 3?
Because 2 has to go on 3 so that you can get the biggest number to C.
So did you notice that we're kind of rebuilding our tower each, whoops. That's going to count that as an extra move when I tap that twice. We're rebuilding our tower each time, all right?
And then
Now which way?
Left.
Right,
Right.
right or
you
left?
put it onto C
To see why.
because it's an odd number so it goes to C instead of B.
Okay,
now
so,
A.
which is now A, okay. So odd numbers go to C. So you have to kind of keep track to keep our minimum number here. Where am I putting 1?
B.
Excellent. However, we had an unnecessary number of moves. That's when I double tapped it, but it was 15 moves. So, good job. Now for our 5th, when we had 5 discs, we didn't have 5 discs on our manipulative. We only had 4 here. So how did you figure out how many moves it would take for 5 discs? Who figured that out? Joseph, what did you figure out?
It would take 31 moves.
31. That seems a lot from what we have. Why do you think 31?
Because 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15, and 15 plus 16 is 31. I
So
saw a
you
pattern.
noticed the pattern. Excellent. You saw a pattern. Tell me what your pattern is. What's the pattern here?
The number you add to the one before is double each time.
It doubles each time. So you added 2 here, you're going to add 4, you're going to add 8, you're going to add 16. So by your rule, what would 6 discs be? What would we add?
63, yeah.
We'd add 32 and get to 63. It's getting big fast. Now what we want to develop is a function rule of x. So we can see this pattern here, but with x, we don't know what the one before it is. So we don't know how much we'll be adding. So now let's look and see if we can see any kind of pattern that relates to the number of discs. See anything? This is where it gets tricky, so I'm going to give you a hint on this. Instead of looking at the numbers 1, 3, 7, 15, 31, 63, let's look at one more than this number. What if I have the numbers 2, 4, 1 more than 7 is 8, 1 more than 15 is 16, 1 more than 31 is 32, and 1 more than 63 is 64. Do you notice anything about these numbers?
They're all binary.
They are binary. What's binary?
They're all
Okay, Daniel's
Powers of
saying
2.
2 times 2 is 4, times 2 is 8, times 2 is 16. And
All
Joseph's
powers of
saying
2.
they're powers of 2. So if I'm going to look at powers of 2, I'm going to say the first one is 2 to what power?
2 to the power of 1.
2 to the power of 1. What's the second one? 2 to the power of 2. The third one? 2 to the fourth. You guys are really quiet.
2 to the 5th.
And
2 to the 6th.
do those relate to our number of discs?
Yes.
Yes. So we almost have a formula, but this is one more than our number of moves. So what do we need to do for our x?
Subtract.
What do you think, Daniel?
You take 2 to the power of x.
So 2 to the x minus 1. So what 2 to the x is what 1 more than it's going to be, and we're going to have to subtract 1 from that. All right, so when we think of this in terms of a function, what's our input to this function that we're making? What's our input here? Number of discs. So we have the number of discs as our input, and what's our output?
Number of moves.
The number of moves. What's our rule? How are we going to write this as a function rule?
F of x equals.
F of x, so what we put in, where x is what?
Is
What's
the
x?
number of moves.
Number of discs. So f of x, our function, is
2
To the x
to the x minus 1. Excellent. Now for the rest of this worksheet, I have a little legend. We're going to apply the rule, and then you're going to flip it over on the back, and you're going to graph this function. You're going to have to figure out the x-axis and the y-axis, and so that you get about 6 values on there. Thanks so much for participating, and that's our lesson for today.